Hi guys, okay, so this is a little video introduction to this Animation Notes audio visualizer. I mean, I don't expect us to be using it, although it was just a really good exercise, and I want to show you the scope of what I did and how many dials and knobs it has and different ways it could be used. Just to start off with, here you can see this is the node setup. I've tried to, it's not my best in terms of laying out all the tracks legibly, although I've tried to make it so that you can follow it. The one thing I haven't got is all of the inputs in one place, which is what I would like to do. I haven't had the time to do that, so all of the dials and knobs are scattered all over the place, so I'll talk you through it. So here we go. So what you've already seen. So we start off by baking in some audio. We bake the average and the spectrum, and as you can see here, I've sort of baked a shed load of frequency bands. That's to kind of just get more information in. So then we are piping out the sound average and the sound spectrums. Now over here I've tried to label the frames that everything is in. So we're setting up, so here we are setting up parameters that will run the loop. So here this top frame says set radius and amplitude influence. So here we basically set the radius of the first ring, and we set how much shifts in the average amplitude will make it change, like boom, boom, boom. So if I just set this playing, I'm not sure if the audio from this is going to come through on OBS, hopefully not. So here, if I change the radius, you see it. Oh, no. Whoop, 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 whoop. Yeah. So you can see that's getting it down really small there. So set it back to 0.1, and then if I set this one to 0, you can see that the audio, the radius isn't changing. All that's happening is we're getting extra rings as the music plays. But if I switch this up, you see the rings are actually changing in size. So that's what that does. So stop it playing. So that's what this part does. Here, this frame, generate curve objects. This is the interesting bit, because what we can do, if I just go down to a frame further into music and view it from the top, here we can set the number of rings, and if we want to have a constant number, we can set it here. So I want 5 rings forever, and if I just set it playing, that's all it's going to do. And you can just see that the radius is just changing with the amplitude of the music slowly, but the number of rings isn't changing. And we can scale this number up and scale it down. But the fun bit goes, if we set it to -1, it will then use this frame here. It's going to take the average volume, it's going to do a couple of calculations, feed it into here, and then with this node here where we instance the number of curves, rather than the constant number over here being piped into this for the number of instances, it's going to be calculated dynamically based on the audio volume, and we get this result. And we can tune to a degree how many curves it will create based on the volume with this here. Now what I found is if you do it above 20, we start to lose resolution and you get almost triangular beziers rather than circular. So I've put a little note saying there, keep it under 20. We see if I put this down to 5, we get less rings. Now that's not saying that that's going to be a maximum of 5, it's just going to be around 5, and then the volume of the audio will modulate around 5. I like 10. So that's what that does. And then down here, we just calculate a couple of numbers that we're going to need. So while we piping here we're getting the all of the individual spectrum volumes, and we're seeing how many of them there are, and then we are dividing that by the number of rings, which is this line coming down here. So we're counting up how many rings we're going to create, the instances, sending that down here, and dividing that by the number of individual spectrum bands. Then we round that to an integer, and we send that off to the loop, and we also divide 2 pi by that by the number of rings, not by number of rings, by this quotient value here, which is the number of spectrums. Yes, the number of spectrum bands per ring. We're then dividing that by 2 pi, so that we know this is for generating a mesh later on, so that we know like how many angular steps we're doing. Because each frequency band has got a certain number of volumes in, and that is going to be a point. Every point in the spline corresponds to one of the frequency volumes. So that's what we're doing. It's just a bit of geometry. This box down here, z-scale, will influence how high things go. At the minute, I'm leaving it at 1 because it just looks a bit weird if you scale it up much. But you never know what would be useful, so it's available. I mean, and also we can turn it down really low and we can suppress it. And then the last part of the setup loop parameters frame is we are setting a material, which that's just running a little Python script, because there isn't really a nice way of changing what material an object has. And obviously, especially if we're on auto nodes, auto instancing over here, you're getting curve objects being dynamically destroyed and created, so when they're created they're not going to have a material, so we have to keep assigning them. So we're feeding in all of the current list of objects, we're feeding in the material name, and that's being sent into this script over here, which is basically this. So it's just a little Python loop just setting the material. There's nothing remarkable there. So there we've gotten to the end of this frame, and then we launch this loop, so which starts off down here. This box is just taking the list of like the whole 125 list of frequency bands and splitting them up into chunks for each ring. That's what this is doing. This little thing here is just incrementing the radius for each ring. That could be parameterized, so you get dynamic steps, so you get more steps, or so the steps are like the radial steps are further or smaller the further you go out, but I haven't programmed that. So those like sliced up lists and the other information that we're sending from above all get sent into another loop, which is the loop which basically generates the coordinates for all the spline points. And this loop runs down here, does some pretty simple maths. It's just tracing out a circle, so we've got sine and cos of values, and then sine and cosine of an angle times the radius there, and then with the z value is basically the scaling factor that we saw above multiplied by whatever the volume is from the audio subsystem. And then all of that spits out a list of points, which is basically of the coordinates of the spline. And then we get those, and then so we go back to where this loop exits. It feeds those into splines from points. we smooth out the Beziers with this, and this can be tuned as well, although that value there is pretty good. And then we feed the splines into each curve object. And down here, with the radius of the spline from points, we can scale up the volumes, as you can see there. So we can go for like a really wiry look, or we can really blow it up and make it look like some sort of like Dunlop Man effect. So take your pick there. So just to recap, because I know I've been rambling a little bit, so we can set the number of rings, and we can set the number of rings to be constant or dynamic. We can set the radius and how much the radius is modulated by the amplitude. We can set a single material currently. We can set the z-scale. We can also set how, like roughly how many rings the auto ring generator will make, and we can set the thickness of the splines. And obviously there's like the audio things in here. When we're baking that into an F-curve, you can tune the attack and release so that it's smoother or sharper movements. So yeah, that's my animation nodes audio visualizer, and there's lots more I can think of to do with it, although I want to move on and do other interesting things. This is pretty much done now. Like I say, I would prefer to wire it all up so that I had just a list of input values over here and then just pipe them in. I could do it as like groups and like subprograms in the same way that these loops are done here. Although the problem comes with this auto with the object instancer, that cannot be in a subroutine. That has to be top level, and obviously you can see I've got some logic that goes before that, upscale of it. So I didn't think of a good way to lay it out. So it would be just a case of putting down a column of float and integer values and then piping them all in, so even more reroutes dotted around. So, and I don't know if anyone's going to use this right now anyway, so I'm not going to worry too much about usability. So anyway, I hope you like this. One other thing I'll just show you quickly, what I just did for the material of this. Nothing special. It's basically for some reason all of the curves are coming out with the same object ID of 0. So I couldn't get I wanted a different color for each ring, but they're all getting the same object ID, so I couldn't put that in as a color ramp factor. I don't know why. So I'm basically taking like the Z value of the mesh and feeding that into this color ramp, and then I'm making it partially metallic, partially emissive. That's probably like I didn't. That was just done off the top of my head. It's nothing special. So yeah, hope you like. I'm going to stop recording and upload this to Slack.